my name's Andy. I work for a company called Reactor in Finland. We're a software consultancy, so that's enough of that. As a disclaimer, this is not going to teach you a lot about Kubernetes. Quite the opposite, in fact. Well, no, you're not going to forget things about Kubernetes. But yeah, so if anyone here works on Kubernetes or loves it, sorry. You're probably not going to, well, you might enjoy it. So who in here has, raise your hands if you've heard of systemd, Linux? Okay, quite a few people. So this is my feeling on Kubernetes. It is the systemd of the container world. It does a humongous amount of stuff. It has a lot of features, which is great if you need a lot of features. But for the most part, as far as I can tell, most people actually just want to deploy containers in a slightly more efficient manner to multiple hosts. So, like systemd, it's useful, and from a user's perspective, I quite like systemd, but I don't like when I have to, every time I try and find out something, oh, there's a systemd module for that, and it's hugely complicated, and I give up. So the reason I want to bring this up is because of this architecture diagram, which is deploying of Kubernetes. So the first lesson from this is don't do it yourself. If you're going to use Kubernetes, that's fine, but get a cloud provider to do it, because managing the complexity of running 6 services yourself in the right high availability manner with nothing falling over is, well, a waste of your company's money, unless you're reselling Kubernetes as a service. You should be solving, actual business problems instead. Another thing of complexity in this is there's 6 different protocols to talk to 6 different services, which seems mental to me. Especially as before yesterday in Ben's talk, I think it was, I didn't know what 3 of these protocols were. I've heard of 3 of them and not the top 3. So I want to contrast this with Nomad's architecture, which is this. Nomad being a Hashicorp tool, and in all Hashicorp things, they seem to only want to ever give you one binary. So this comes in one binary that does 3 jobs. Your first one is a command line application, so when you're interacting with the cluster, this runs on your machine. Then you can run it in agent mode. The agent is what orchestrates the cluster of your entire Nomad cluster. We put 3 of these in a scalability group, if you're on AWS, for instance, or 5 of them, and just don't worry about it. Put 3 of them in, make sure they can talk to each other. After that, you can put the assembly into client mode, and you can have as many of these nodes as you want. Again, stick them in a scalability group. Now, you don't have to have these as brand new machines. You can just put this onto your existing infrastructure. So if you've got a bunch of metal machines, or you've got your own data center, or some existing EC2 machines, you can just put a couple of Nomad clients on there and start migrating your application slowly into Nomad. You don't have to spin up an entirely brand new cluster of things to do this. If you want to spin up a brand new cluster, that's fine, and Hashicorp will provide a Terraform file for you, which will do all of this for you. So you don't even need to worry about that. You can just do Terraform up, Terraform apply, not up. And if you want to run it locally, there's a Vagrant box you can use if you want to put it in a VM, or you can just run the assembly yourself. Again, pretty simple. So the next thing I want to talk about on the complexity side of things is what Kubernetes does for you. Like I said earlier, it does a lot of things. Service discovery, load balancing, configuration management, secret storage, feature gates, routing, storage orchestration, auto-scaling, container management, and rollout and rollbacks. And thank God I didn't have to memorize that. There's probably some others that I've forgotten, but like I said earlier, this is great if you need all of this stuff and want all of this stuff. Then, well, yeah, one-stop shop to get everything you want. If you're in a greenfield application and you're doing microservices, sure, use Kubernetes from a cloud provider, not yourself, and you'll get all of this. But if you're a greenfield application doing a monolith, well, there's no point using any kind of container management. You're just adding complexity for, what, CV-driven development? If you're a brownfield application and doing a monolith, again, probably no point using either system. You don't need containers for a monolith. And if you're a brownfield application doing microservices, then you've probably already got a lot of the stuff that Kubernetes does. So why would you replace all of that existing infrastructure with another version of things? We'll get back to that point in a minute. I want to contrast it to what Nomad does. So the massive list is container orchestration. No, that's it. That's all it does. Technically storage orchestration as well. I mean, you can tell it you want a disk to follow your container around. But yeah, that's all it'll do. Everything else that you want to put into your cluster or use is entirely up to you. You can use tools that Nomad supports out of the box, or you can do things yourself. It makes no requirements of using any other Hashicorp products, although it happens to work quite well with them because obviously they'd like you to use them. It also means you don't have to put everything in place at once. So let's say you've got an existing application. You're using Console for service discovery and Vault for secret management, and you've got, say, well, here we've got 2 containers and 3 other applications which use both. Now, it doesn't have to be Console, it doesn't have to be Vault. Not that I know of anything else that really does what Vault does. But so you've got all of this, and you decide that you want to put things into Kubernetes. And so here you hit your first problem, which is that Kubernetes only runs Docker containers. But you've got some other applications which now need to be put into Docker containers if they can be. Like we have some applications in my last company that had to use WCF, which was fun, but WCF doesn't run on .NET Core, so you can't put it in a Docker container, so you can't put it in a Kubernetes cluster, or anywhere else really. Except you could if you used a Windows container, but a Windows container is like 10 gig. It's not a container at that point, it's a VM. So you might not be able to put everything into Kubernetes. But if we ignore that problem to start with, you don't want to do a big bang release. You want to try and put pieces at a time into your system, because big bang releases are asking for failure. So you've now got to try and translate service discovery that you've got outside your Kubernetes cluster with service discovery inside your Kubernetes cluster. Now, Kubernetes provides its own service discovery mechanism and its own secret storage. But that's not the same as whatever tooling you've used, because it's internal to Kubernetes. It's not just it uses console, so you have no problems. It's using its own thing, so you've got to write some translation here. There's also the added difficulty of how on earth do you synchronize 2 secret storage engines? Because you've got to somehow share the secrets between them. So one of them could do a lookup in the other one, but that's not fun. Or in the case of Kubernetes, it stores all your secrets in plain text in its etd. So you could just query them out of that. Whereas Vault definitely doesn't support them in plain text anywhere. If we compare this to if we did the exact same thing with Nomad, we'll see that the graph gets or the diagram gets completely different. And it's got a green logo and the lines became blue rather than orange. And the reason for this is because although you do need to keep your service discovery working between both clusters now, there's no translation involved. Nomad's not requiring you to use console. In fact, if you're not using console, it doesn't care. Your applications just keep using it. You can deploy console inside your cluster as well. Or you could just keep querying the hosts. So while those 2 components are still involved, they're optional, and you don't have to use them, and you don't have to have translation. So hopefully you've reduced some complexity, at least in your migratory phase. And there is one other slight advantage to Nomad, which I love beyond all things, and if both products were identical and Nomad had this advantage, I would still pick it. Oh, it's no YAML. God, I hate YAML. I'm not going to rant about YAML because I could fill hours about that. Let's suffice to say, if you've ever tried to put Norway in a short piece of text for an abbreviation as NO, and then realized that it's become the word false for some reason, because there are 23 different ways to represent a Boolean value in YAML. Anyway, we're not using YAML. We're using Hashicorp configuration language, which is pretty much JSON, except no commas, and you can comment things out, which makes it great. So this particular example is a job specification for Nomad. A job can contain one or many groups, and a group can contain one or many tasks. In this case, we have a single group, and it's got two tasks. It's got an app and an Nginx container. Both are Docker containers, and we want them deployed together, so we've put them in the same group. When you run a job in Nomad, it'll always make sure that all tasks in one job are on the same node. So if we've got two Nomad nodes, and we deploy this job 3 times, we'll get 3 copies of it, but the application and the reverse proxy will always be on the same node. So you don't suddenly have a giant amount of network bandwidth between your application on one side of your data center and your reverse proxy in a different data center, because that wouldn't be great. If we zoom in a bit more on the actual task definition, this is one for RabbitMQ, which we'll launch in a second as well. So we have the driver set to Docker, and we'll get back to what else you can do with that later. We're using a particular RabbitMQ container, which I've got configured for service discovery and other such fun things. Don't use that container in production. It has guest accounts enabled and all security disabled because it makes demos easier, but production less secure. So don't use it. Disclaimer done. We set the host name, and then we also specify that the Docker container is going to expose 2 ports. Now these ports are then referred to throughout the rest of the configuration file, in this case only in the network stanza. Because I haven't defined what port number to use in that network stanza, Nomad will just assign a random port and pass all traffic through to the container. This means that we could run all 3 copies of our RabbitMQ node on the same host, which would not be very stable, but we could. And it'll have different port bindings, so you won't end up with port clashing. We can also specify CPU and memory requirements. It also has the ability to specify the number of IOPS you want for a disk. But while doing some reading this morning, I discovered that that IOPS setting is totally ignored. So you can specify whatever IOPS you want, and it'll just ignore it. The next version of Nomad removes the actual use of that and marks it as deprecated. So as fun as staring at config files is, let's see if my demo works. It didn't this morning. Right, so let's check this is up and running. Where has my cursor gone? There we are. Right, so we have 3 Nomad nodes running. So I've got 3 virtual machines running on my machine. One of them is also acting as the server as well. So what we're going to do is make that a lot bigger. Let's also clear it as well. So the first thing I need to do is set an environment variable so that it knows where the Nomad cluster is sitting. In this case, I have a server IP file written out onto disk because I got fed up of typing IP addresses. And we can just check that it actually runs. You know how it's hard to type when someone's watching you? It's much, much harder when there's an entire audience. So let's have a look at our job file. Hopefully this is big enough to see at the back. Yeah, good. So this is the same file that we were looking at earlier, except I've also got some additional blocks in here. This just tells how we deploy multiple containers. If you had a cluster of any sort, doesn't have to be RabbitMQ, of say 10 nodes, and you decided to update those 10 nodes, and you didn't have this specified, it could just shut all of the nodes down and then start up 10 new copies, which wouldn't be great for high availability. So in this case, we've told it that it's allowed to update 1 in parallel, and if it's migrating nodes around, it's still only allowed to move 1 in parallel. We're using service discovery through console, because I like console, to find where my registry is. And we've got some extra ports defined, some environment variables that are not that important, other than don't set your Erlang cookie to that value. It's terribly insecure. And here we've got 2 static ports defined. So this container has to expose this port on the host and this port on the host, rather than letting Nomad do dynamic allocations, because RabbitMQ does not play nicely if you try and cluster it on different ports. And finally, we've got some service discovery here as well, which will map RabbitMQ into console later. So let's try running it. Nomad job run rabbit/rabbit.nomad. Good, that worked. Well, at least it seems to have worked. So if we go back into our UI, we can see that we have one task running. We have the name of our group, which I've called cluster because I'm imaginative. And it's got one allocation, so one container running. And we can see here, let's see, let's go in again, that we've got the 4 ports defined, and 2 of them are static, so I've got the values in the config file, and 2 of them are dynamic. So if we go to this, oh good, it does work. This was the bit that didn't work this morning. And we use our super secure username and password. Can anyone guess what the password is? No, I'm not going to save it. As fun as that would be. So we have an instance of RabbitMQ running up, which is good. But this isn't great from a high availability point. I've mentioned clusters a few times, and if you're doing microservices, you've probably got some kind of queuing system involved. If you have a single node running, you're asking for trouble. So let's up this. Let's have a few more nodes. Now, because I've only got 3 VMs running, I can only have 3 of these running. If I put more, then we'll get some failures. So all I need to do here is say that the cluster group, I want 3 instances of that running. And that's all I have to change. Rather than running the job directly, though, let's plan it. Right, let's make that a bit bigger. Yeah, that'll do. Right. So we can see here that the group called cluster is going to be updated. It's going to create 2 more allocations and 1 in-place update. It's not actually going to change anything. And the count of tasks has gone from 1 to 3. We also have that it's worked out that it can successfully place all of these allocations in. So because of that CPU and memory indication earlier, if my hosts had run out of either of those resources, you'd get a failure back. We also have a check index here. Now, the purpose of a check index is so that if someone else has updated this job while I'm currently talking, which is unlikely because I have the Wi-Fi switched off, if I was to run this after someone else had updated the job, my attempt at running it would fail because someone else has updated it. So hopefully things are safe to do. So I'm going to run that command, and hopefully it'll work. Good. So we've got a single modify and a crate and another crate. So I'm going to switch back to this screen and just hope that we get some more lines appearing here. It should work. It normally does. So because I've got those ports set myself, like I had to have that dynamic port set. Oh, 2 nodes. Now node 2 normally gives an error message briefly before it joins. No errors. So we now have a running cluster. So I could go and delete nodes and recreate things now, but I'm not going to do that for now because this is only a 40-minute talk. But that's how easy it is to get a cluster up and running in Nomad. No, come back. Yeah, and there's one other thing to mention. Because I'm using this particular named version of the container, Nomad will always use this version. If, however, I had latest here, whenever the job is rerun, Nomad will try and fetch the latest version of the container. So if you want to just do an in-place update, so version, I don't know what the current version of RabbitMQ is, but if you want to just update to the next version of RabbitMQ, you can just run Nomad job run and the name, and it'll just pull the newer versions of the containers. So that's it for that demo. I'm going to confuse camera people by standing up again. So we've got our cluster of RabbitMQ nodes coming in. Now, if we had an application with some kind of architecture like this, so we have a huge amount of incoming messages into our cluster, then we have a bunch of processors, They write some data to a Postgres database, and then we have a single instance of an HTTP server that lets you fetch that data back. If we had this, where do our nodes connect to? How do these consumers know where to find RabbitMQ in our cluster? So we've got 3 Nomad nodes running, and we have 3 instances of RabbitMQ. Luckily, we have a cluster size of 3 and RabbitMQ size of 3, but the ports are randomly assigned here. So you can't just try and connect to the default port for RabbitMQ. You could make it a static port, but it's generally not advised to do static ports inside Nomad stuff because you might end up with 2 tasks on the same machine. And now one of them's going to fail because the port's already bound. So rather than connecting to your 3 nodes and iterating all the ports until you find one that happens to be talking the RabbitMQ protocol, which would not be fast, you'd need another way to do it. Gets much worse if you think that 3 of these nodes have RabbitMQ on, but the others don't. So now you need to figure out where that is running. And as Nomad could move that container to a different node while you're looking, it gets infinitely harder to keep following things around. So to solve that problem, we use service discovery. Now, as I've mentioned earlier, you don't have to use console, but it is built into Nomad how to do service discovery and registration into it. So you can use the service block and say, I want to register a service called RabbitMQ, and the port is that label from earlier. So we've not had to re-specify that port number anywhere in the same configuration file. We just said, whatever port you've exposed it on, write that into configuration. We have a second service registered with the same name, but a different tag. That's the UI port. Maybe you want to register that into service discovery, maybe not. An administrator might find it useful. Once it's registered into service discovery, for querying on console, you can either use console's HTTP API. In this case, we're querying for a service called RabbitMQ, and we want the AMQP port. In code, if you're using C#, there's a console client library. Basically the same thing. Query the HTTP API on your local machine for where RabbitMQ is. You'll get an object back, which is an array of all of the nodes that match. They come back with an IP address, port numbers, names, and an ID which we can ignore. And so you can now feed that into your code and use that to connect. The downside to this is there's no load balancing. You could pick array element 0 every time. And assuming ordering was consistent, all of your clients would be connecting to Nomad 1 for RabbitMQ, which is, again, not great because you kind of want to distribute that. The easiest way of doing load balancing is just to pick a node at random. So if you're going to start 10,000 consumers, just say, pick me a random consumer out of this a random node and connect to that. If you want proper load balancing, there are plugins to console called Fabio, and that will let you do load balancing better. But as mentioned, if you're not using console, I'd advise you to have a look at it, because it is great. I mean, Hashicorp should pay me. I love their products. They don't pay me. But if they want to send me some swag, I'd love a Nomad hoodie. But yeah, if you're not using console, you don't have to. You don't have to use the inbuilt service discovery mechanism. You can just keep doing service discovery yourself in your application through whatever method you want. In the case of our demo code, if we go back and look here, you see here, I'm also passing an environment variable into my container, which is using this special Nomad environment variable. So the container itself knows what port is publicly exposed. So if I want to use that port internally in the container for something, and in this case, this container actually does the service registration itself internally, I can pass that port in. So you don't have to be aware of Nomad at all inside your applications. Ooh, demo time again. Because demos are much more fun than looking at slides. Or at least I think they are. So hopefully, good, we have Rider open. As a .NET developer, I haven't launched Visual Studio in years. It's great. I only use Rider. So this is our producer application. It's using service discovery internally. So I've got here That's where the snip of code came from earlier. So I'm looking for a node for RabbitMQ, and then I'm building an address for it, and then I'm just publishing 1,000 messages. So that's the publisher, which is incredibly boring. Let's look at the consumer, which is also fairly boring, because I was going to do all the database writing, but then I realized that I was adding more complexity to a talk, which I'm explicitly saying I don't like complexity for. So I didn't. This is exactly the same, other than we are reading our configuration from a settings file and from environment variables. There's nothing particularly interesting in them other than a queue name. And again, we're looking up where RabbitMQ is, but this time we're doing random load balancing by just picking one of the services that comes back, and we'll connect to that. So let's run the consumer. Nomad job run. Now I've got to remember, I probably should build it first. Build. Also, as a .NET developer, I use a lot of shell scripts. I still hate PowerShell. Turns out that I hate a lot of things. Right, so now that I've built the application, let's run it in Nomad. So I don't know how many copies I'm going to ask for. Oh well, we'll find out. Nomad job run. You can also plan a job that's not been run before as well if you want. So consumer.nomad. I think that's right. It is. Ooh, okay. I'm launching 5 consumers. Good. So if we go back here, we should see in our job list, there we are, consumers are already running. And there's 5 of them running, and they appear to be happy. So let's go and have a look at one of them. Yep, okay, we have a consumer running, so if we look in here on our connections tab, and then refresh it, for some reason it doesn't show the node straight away. Yeah, you can see some of them are joining node 1, and some are joining node 2, and none of them are joining node 3, which I think means I have an off by 1 error. Oh well, it doesn't matter for the purposes of this. So let's go back into here and run our producer. Source producer. Good. Good. So we're publishing 1,000 jobs. Jobs are not very interesting. They've got a GUID and an integer in them. I just wanted something. So if we look at queues, let's make that a bit bigger as well. And this one is slightly more interesting, so we'll make that bigger as well. So we've published a bunch of messages, and we're now delivering messages at about 4 messages a second. So our consumer's not doing anything particularly interesting with them. Consumer program. On every message, it's just pausing for a random time delay of 0 to 5 seconds, and then saying that it's successfully finished processing something. Now, while we can see that things are being processed from inside RabbitMQ, it would probably be quite useful to see what's actually happening. And we can just go into the logs tab on Nomad, and now we can see the console output automatically from our running task. As you can see, it's just processing jobs slowly. Now, what we can also do is come back into here, consumer, Nomad, and let's drop our number of consumers down to, let's do 1. Because I trust that none of you have been interacting with my cluster while I've been talking, I'm just going to run it rather than planning it. If you have been interacting with it, please tell me how, because like I said, Wi-Fi switched off. So if we look at the consumer, we can now see that 4 jobs have been marked as completed. That's because they've terminated successfully. They go very red when problems happen. So 4 of them have completed, and 1 of them is still running. So complete that one. And we can go and look at its logs, and you can see that it's still processing. And if we go into RabbitMQ, we can see that our message rate has gone down significantly since updating our number of consumers. So that's it for that demo. I'm going to leave that running in the background because why not? So the other thing I want to mention in this is my super secure username and password, which again is a bad idea, but for demos makes things a lot easier because it's nice and short to type. But we should not be doing this in production. Credentials and application security is another talk that I give around, would you believe, another Hashicorp product. Because secrets should remain secret. And not only should they remain secret, is things like RabbitMQ connections and database connections, you shouldn't be having a very long-lived credential for them, because that could fall into bad hands. Ideally, you want nice short-lived credentials that run for either the duration of a process or a few days, few hours, depending. We have several different types of credentials. There's the ones that we want to be dynamic and short, so that's things like database connections, RabbitMQ connection strings. And then we've got static credentials, things that can't change, like API keys from, say, Twilio or something. They're not going to let you rotate the keys on a very regular basis. To handle all of our secrets, I like to use Vault. Again, send me swag. Vault is compliant with a bunch of federal regulations on data processing. It stores things securely, and it integrates directly with Nomad very easily. But again, you don't have to. You can use Amazon's Amazon Secret Management Service. It's probably called something like that. It does have a secret management service, but it doesn't quite go as far in scope as Vault does. Vault, for instance, can generate keys for different applications. So your application can say to Vault, give me a connection string for RabbitMQ. And Vault will talk to RabbitMQ, generate you a connection string, give that information back to your application. And you authenticate against Vault, and it can authenticate against AWS, GitHub, and Azure, and many, many other things, including LDAP. So your developers can use this on their local machines as well. Now, you can put this configuration in your application, but like I said, Nomad supports it directly. There are pros and cons to using Nomad's integration into Vault. They basically work in the same way. So in your application, you just read the credentials. You say to Vault, I want secrets for RabbitMQ, and I want the consumer role. Doesn't matter what the consumer role is for now, but you can just request a role, and you'll get some username and password back, which will work for a while. Or you can put it in your configuration file. So in our Nomad file, we can use this template structure and say, with the secret, and then that consumer role, write out a JSON object that contains the username and the password. And your application, as long as it knows how to read a JSON file, will get a username and password back. Like I said, there's pros and cons to both of these methods. If you put the Vault integration in your application, then you can do things like monitor how long you have left on your lease of your credentials, and then refresh them before they expire. And you can do things like refreshing them in general. But you do have to know where Vault is, which you could do with service discovery, and you have essentially more complexity. If you put it into the Nomad file, you're removing that complexity from your application. Only Nomad needs to know where Vault is. The downside is when that expires, your application should crash, and then Nomad will restart a new copy of your application with a new set of credentials. So as long as you're fine with occasional stoppages of your application when its credentials expire, you can save a lot of complexity by doing the integration directly. There is one other thing that I want to point out. When I ran that application, did you notice the Docker container I used to run it? Because there isn't one. Nomad doesn't have to use a Docker container. You can use a Rocket container or LXC, which I've heard of, or you can just use an executable. In the case of my application, I just zipped the publish directory and then ran the consumer DLL using the .NET installation that was already on the host. Where did it get that from? Well, I used service discovery, again, to fetch it from an HTTP API. So if you want, and you don't want to use a Docker container because your application's not already Dockerized, you can just zip it up and stuff it anywhere. S3 compatible APIs work, HTTP APIs work, and I think Samba shares as well. So if your application can't go in a Docker container, or you don't want to put it in a Docker container for some reason, you can use it directly. I mean, you do lose the advantage of a container where you have that isolation and you have a single unit that you know will work. But at the same time, if you've got that .NET application that needs the full framework, then I don't have to make a Windows container from it. I can just have a Windows box with a Nomad client on it and add to my configuration that this requires Windows. Nomad will allocate it to a Windows machine and fetch and just run .NET. So if you can't Dockerize, this is the way to do it. It'll also automatically extract the zip files, so you don't need to write zip code anywhere either. That automatically gets extracted into that local directory. And one more thing, to quote someone much more famous than I am. You don't have to do just long-run services with Nomad. You can also do batch jobs and system jobs. A system job runs on all clients in your cluster. So if you wanted to make sure that console was available or your service discovery mechanism of choice was available in Nomad, you can mark it as a system job and it'll make sure that every machine has a job running on it. The batch jobs, well, let's say you're working for Pixar and you've got 10 billion frames of a new movie that you want to render. Well, you can just queue up 10 billion jobs into Nomad and say, run these batches, and it'll make sure that they all get allocated into the right places. They run, and if they successfully run, they're removed from the queue. And if they don't successfully run, it'll rerun them based on your retry policy. So if you're doing batch processing or stream processing, you can also deal with it like this. So that was my lightning overview of Nomad and other Hashicorp products. There's some links here. The slides are available online. The demo, I think, is already published. If not, I'll try and remember to git push it afterwards. I'll leave these up there. So that was it. What questions have you got? Or are you all stunned into silence? Oh, there is a question. So the question, if I get this right, is there a way of testing that your Nomad file will work when you actually publish it? Not directly that I'm aware of. I mean, you can do the Nomad plan, which will tell you that it will try and allocate it into the right places. And you can also specify constraints in the file as well. So you can say, this requires this version of Linux, or the machine has got to have this faster disk, and that other kind of thing. So you can do that kind of testing. But there's nothing to stop you running a Nomad cluster on your machine, which is what I'm doing. There's probably more stable ways of doing that. But you could have a separate cluster to test things in. But I'm not aware of a specific Nomad test command, although that would be quite useful. There's probably someone more intelligent and knowledgeable around that can answer that question better. All right, anyone else? Yep. Oh, microphone.
Hi.
Hi.
Any tools or integration with continuous delivery deployment pipelines, such as Azure DevOps or I don't know?
Not directly. Okay. So like if you want a continuous delivery pipeline for this, essentially you just use an executable task and just say Nomad run and this container. I wouldn't be surprised if there's something in Spinnaker for it, but I haven't checked recently. Okay, I don't see anyone else, so thank you very much for coming.